All right, we're going to look at logic part 3, which is going to explore something called the conditional. So oftentimes statements are made up of multiple parts so that if a condition is met, then an action is performed. So this thing is called a conditional. Basically, again, it's a logical compound statement. It has a statement P, which is called the hypothesis or the antecedent, and a statement Q, which is called the conclusion or the consequent. And it's written with this little forward-facing arrow where we say something like, if P, then Q. Or sometimes we'll say P implies Q. So let's look at this exercise 1. Suppose that you order a team jersey online on Tuesday and want to receive it by Friday so that you can wear it to Saturday's game. The website says that if you pay for expedited shipping, you will receive the jersey by Friday. In what situation is the website telling a lie? Explain your reasoning. So let's say that you paid for expedited shipping. Well, it said on the website that if you paid for it, then you would receive it by Friday. So if we did pay for it and we received it, then they're doing their job. It's true. Now, if we pay for expedited shipping and we don't receive it by Friday, well, then that would really be a lie because they said if we did do that, then this would happen. So we did not receive that jersey by Friday, so that would be considered a lie. For the next situation, it says you didn't pay for it. Okay, I didn't pay for it, and I received it by Friday. Woohoo, save some money, and I got it on time. There's no lie going on there. It's all good. For the last one, you don't pay for expedited shipping and we don't receive it by Friday. That was basically the expectation because I didn't pay that extra money, so there's no lie going on there. So the way that this fits into the truth table, you might be already able to tell. I'm going to put in my standard column for P, which goes true, true, false, false, and alternating for Q. And so what we're saying then is that if P implies Q, if both P and Q are true, well, it'll be true. If P is true and F is false, that's basically you did not follow through. The website did not follow through here when they said I would receive it by Friday, so it's a lie, or sometimes I'll even say like a broken promise. Now, the rest of the time, even though it's starting with a false premise, it doesn't matter. It doesn't affect what happens here. So we're going to say true. There was no lie going on there. Basically, false could imply anything. So there's nothing wrong with those statements. So they were all true. So there is only one time that we're false, and it's going to be this one time when we have that broken promise. So if our premise or our hypothesis is true and our conclusion is false, then we'll get that broken promise situation, which leads us to having that false overall statement, truth value. All right, flipping over to the next page. We need to create an English phrase. So please create your own phrase for this. So remember, this upside down V is and, the little squiggle is not, and then now we have that forward arrow, which I'm going to write implies, but that's that conditional. So we can start by saying if, then, since we know we have that forward-facing arrow. So if, let's say that, let's say I eat pizza. That'll be my P. And let's say something I don't do. I don't drink pizza. I mean, I don't drink soda. Then let's say I am full. So just pizzas makes me full. So let's construct our truth table. And just a little note, it says one outcome will be false overall. So let's think about what this means. We do have 3 statements here. So we have the 8 rows. So we're going to fill in half of them with trues, the other half with falses for my P. Q, I'm going to do 2 at a time. Again, this is just kind of the standard way to fill it in to make sure we get all the possibilities. And R will be alternating. And so when we want to look at not Q, it's going to have the opposite truth values of that Q. So it's going to go false, false, true, true, false, false, true, true. When we look at and, we want conjunction. Remember, they both have to be true. So we're looking at the P column along with the negation column. So if we look at true, false, that's going to be false. True, false, that's false. True, true, that'll be true because they're both true. Again, that's happening. And then the rest of these are going to be false because there's a lot of false going on in there. And so for the last one, we want to do the conditional of that previous column going to R. So this P and not Q implying R. So the only time, remember, that the conditional is going to be true, is going to be false, is if we have true going to false. So we have false going to true, that's okay. False going to false, that's okay. True going to true, that's okay. True going to false, that is false. That's that broken promise because the hypothesis was said to be true, but then it didn't follow through. We have false going to true, that's okay. False going to false, that's okay. And you can see all of these are going to be okay. So the only time here that we have an outcome being false is this row. And what's happening here is that we have P being true. That is, I eat pizza. And we have I don't drink soda being true. And then we end up that our conclusion is false, which means we have broken that overall promise. So again, it's saying that I eat pizza and I don't drink the soda, which was my hypothesis. So that's all true. And then my conclusion doesn't follow through. So the conclusion was supposed to be that I am full, but it says right here that that's false. So we have that broken promise. Or lie, if you want to see it that way. So if the hypothesis is true and my conclusion is false, then that's my problem. Now, there's a few different things that we could do with the conditional and see some different relationships. So if we kind of flip-flop the order, that's called the converse. So if you have P and Q, the converse of that would be then Q implies P. We have the inverse, which is really negating the original statement, so not P implies not Q. And lastly, the contrapositive, which is really a negation of the converse. So let's see what that kind of looks like with some actual English sentence that we have here. So it says, if it is raining, then there are clouds in the sky. So we have that P is, it is raining. And we have Q being, there are clouds in the sky. So for the converse just switches the order. So we're going to say, if there are clouds in the sky, then it is raining. For the inverse, we're going to say, again, that's the same as the original, but just negated. So we're going to say, if it is not raining, then there are not clouds in the sky. And then lastly, for that contrapositive, okay, that's the negation of the converse. So I'm kind of looking at the converse. So if there are not clouds, then it is not raining. So if we think about which ones might be equivalent, I'm kind of drawn to that converse and inverse actually, because they're saying that if there are clouds in the sky, then it's raining. And then they notice that if it's not raining, then there are not clouds in the sky. It just kind of seems like kind of opposites of each other. And then as I'm looking at that, it seems like the original with the contrapositive are also kind of saying similar things, that if it is raining, then there are clouds in the sky. So if there aren't clouds, then it's not raining. So the way to kind of double check to make sure that those statements are in fact logically equivalent is to do the truth table. So we're going to fill this in. True, true, false, false, true, false, true, false. Negating our P would be false, false, true, true. Negating our Q will be false, true, false, true. Okay, so for our conditional, that's our original, P implies Q. Remember, the only time that it is false is if you have that broken promise. So we're going to look this direction, P to Q. So it will be true, false, true, true. For the converse, we're going to look the other way, Q to P. So Q to P, we're going to get true implies true, false implies true, true implies false. That's our only broken promise. And then we'll get a true. For the inverse, that's looking at the not P to not Q. So going in that direction. So that's going to be false to false, that's true, false to true, that's true, true to false, that's the broken promise. And then true to true is true. And lastly, we're going to go the other direction, not Q to not P. So that's true. There's our false one, the broken promise. And then the rest of these are true. So you can look at their ending values here and see that, in fact, the conditional is logically equivalent to the contrapositive, and the converse is logically equivalent to the inverse. Okay, and so flipping over here to our almost our last pages, let's kind of think about the negation. Let's see. Consider the statement. If you park here, then you will get a ticket. In order to prove this false, remember, we're going to, or kind of say that there's a lie, is that if you do park and is true, then getting a ticket, if that doesn't happen, that's when we're going to have a false statement. So when we kind of think about negating this statement, in other words, another way to say it's not true that if you park here, then you get a ticket. You could really say that you park here without getting a ticket, right? That's what's happening. And so really what's happening, you can kind of see, is that the negation of the conditional statement is logically equivalent to saying the hypothesis and the negation of the conjunction of the hypothesis and the negation of the conclusion. So you can see not P implies Q is really equivalent to saying P and not Q. So let's think about that for a second. Let's write the negation of that statement using that form. So if you park here, right, you park here is our P. You will get a ticket is Q, so the not get a ticket would be happening. So we're going to say if, okay, sorry, oops. It's a conjunction, so we don't have to put the if in there. We're going to say you park here. And you don't get a ticket. So let's verify that with the truth table to see if this is really that these two have that same equivalency. So to complete this, we're going to need a negation of Q, and then we'll need a P implies Q. We'll need that conditional. So filling this in, true, true, false, false, true, false, true, false. The negation of Q would be all the opposite truth values. And our conditional, remember that's only true or false if there's a broken promise. So true implies true, true implies false. There's our broken promise. These ones are all okay. So then our negation would be false, true, false, false. And so notice that a conjunction is only true if both of the things are true. So we're going to look at that first column and the third column. So it's not going to be true. There we go. There's our true part. The rest of these are false. And so these are logically equivalent to each other. And so again, you can see that the only time that we have that true happening is when our we did park and we did not get a ticket. We have that truth. All the other times it's false. So there's some statements called biconditionals. They are true regardless of which direction, because we've kind of been putting the arrow forward. And a biconditional really is when a conditional and its converse are both true. Since the truth works both ways, we will denote with like that double-sided arrow, which is red P if and only if Q. So an example would be I'm breathing if and only if I am alive. So the two conditionals represented there are if I am breathing, then I am alive. And then going the other way, that if I am alive, then I am breathing. And so we're saying that those two conditionals combined is what we're really looking at for that biconditional. And so when we look below and it says that a conditional is equivalent to the contrapositive and a converse is equivalent to its inverse, if you look at those statements that we have, we call the first one our original. What we have done is written the converse here. And so we know that since the conditional and converse are true, if the conditional and converse are true, the original, then the other statements are also going to be, because we have that equivalency here. And you can kind of, if I write them, if I am not alive, then I am not breathing. And the other statement, if I am not breathing, then I am not alive. You can see how these are going to actually all be equivalent to each other. And so we'll verify that by looking at this truth table here. So we have that, really, that biconditional. We know it's equivalent to saying that both of these things are occurring. And so if we put true, true, false, false, setting this up like normal, we're going to get, again, the only broken promise is right here, so everything else is true. Going the other direction, our broken promise is happening here, so we're going to get, again, going that direction, true, true, there's our false, true. And so the only time that both of them have the same, have all that true, I mean the conjunction is true, is going to be that first and second. And so we could say, I'm just writing this for that last column because it means the same thing as that. And so what's happening really, it says explain why the two truths occur when both the hypothesis and conclusion have the same truth values. Well, really that's happening because in the other two rows, you could see that if they have opposite truth values, then it's going to be false in one of the directions. And so for our biconditional, we want them to work in both directions. So the only way that that's going to happen is false going to false and vice versa, and true going to true. So really they must have the same truth values. If this thing happens, then that happens, and that happens, then the other way around. So hopefully that makes a little bit of sense. Which is that if P is true, if and only if Q is true, and then P is false if and only if Q is false. So that's it.